Okay, so today's notes are really just a whole bunch of examples. So, let's give them a try. Brad's already noticed that the bottom right here you have log 2 plus log 2. Before I even point out what Brad pointed out, one thing I'm going to say a lot today, don't forget, log 2 is just a number. If you get absolutely stumped at some point, don't freak out. Just recognize that this is a number. That's a number. That being said, log 2 plus log 2, there's a rule about adding two different logs. It's the same thing as multiplying. Does that make sense? So one thing you could do is you could make the bottom of this thing be log 4. That's a way that would be useful. I also have another idea. You see how the top right here is 2 and then log x? I'm not saying this very well. Does that make sense how I can bring the x, like it's squared up? That's the power rule, and I'm just kind of using it backwards. So then what I could have is I could have log x squared minus log x. I guess still equals 4. Now that I have that 2 up front, what happens when you subtract logs? Collectively divide them. Does that make sense?
So with the log x
Let me draw it out for you. Let's see if this makes sense. It's going to be log of x squared over x divide by a log of 4. Sean, I'm guessing your thought was we could take the second x and put it on the bottom with the log 4?
Yeah.
But it wouldn't work like that. What ends up happening is it goes on the bottom of a fraction, but the fraction is still contained within the first log, not on the bottom of the other log. Okay, you have a lot of options from here. I've been saying for a while, don't forget log 4 is just a number. So you could take that number and throw it up to the other side. That would work. So at this point here, can I try to show you two different ways that I see at this point that I can solve it? So like method 1, let's put like a little 1 here. Let's times that log 4 up to the other side. And what you'd have then is log of x squared over x would equal 4 times the log of 4. You know how earlier I brought like the number in front up as an exponent? I can do that again here. Here's this 4. I'm going to bring it up as an exponent. That's valid. Because at this point here, there's something clever that I kind of want to talk about. A log is an operation. It's a mathematical tool. And if you add something to both sides, that's valid. If you multiply something by both sides, that's valid. If you add an exponent to both sides, that's valid. I guess the point I want to make here, do you guys see how there's a log on both sides of the equation? Yeah, I can. Yeah, that's the point I wanted to make. Now, you can't cancel under all circumstances, only under a very specific circumstance. It has to be the log of just a single thing equaling the log of a single thing. So you know how that 4 was sitting in front there? I couldn't cancel the logs until I actually removed the 4 and brought it up. But now I can.
That didn't have to have the same base.
They have to have the same base, which they do because neither actually has a base. So 10, I guess, is the base. Sorry, Joanna, I kind of interrupted you. Did you say
no,
a question?
I'm not.
You're good? Okay. Okay, so I guess at this point here, what we're left with is x squared over x equals 4 to the 4. What's x squared over x, though? Yeah, we probably could have simplified that a while back. So 4 to the 4 is our answer, whatever that is. 256? So one of the things I wanted to show, I think, in this example, at least the first way I was going to solve it is you can, under the right circumstances, remove a log from both sides of the equation. That would be valid if you do it right. I did have another idea up here where I wanted to go another route. Oh yeah, I remember what my thought was. Do you see how you have right here a log divided by a log? We actually also have a rule for that. That's the change of base rule. You guys know that term? This really means that, you know how there's like a base 10 right here and a base 10 right here? We could write this as log base 4 of x squared over x. Because the way that the change of base rule works is you write the log of the big part, and then you divide by the log of the little part. For those of you, I know it's probably just YouTube, where you have to like literally write that in your calculator to make it work. You're probably more comfortable with that idea. But Did that make sense there, the other route I took? I lost you there. Okay, there's a rule that says that log base A of B over log base A of C is equal to log base C of B. Do you know that rule off your formula sheet or from last day? Basically what it means is if you have log base 3 of 4, it's equivalent to log 4, and then you get to divide by log 3. Does that make sense? That's what I did. I'll just write this off in the corner here. This is the top part, and this is the bottom part. So really what happens is you can just write a single log, and you just put the little 4 in the corner. That make sense now? Okay. Going from here then, I see another way I could change this. I could use the rule of how logs and exponents convert between each other, which would be this little base of 4 going to the power of 4 equaling x squared over x. So it would be like 4 to the 4 equals x squared over x. That makes sense? Like I'm changing it out of logarithmic form into exponential form. And then at this point here, is that not exactly what we just had right here? So then cancel the x. X is equal to 256. Two different tricks you can use then. One of the tricks I showed you right here, if possible, you can cancel logs off both sides. Okay. But it has to work like this. Log of a single thing equals log of a single thing. Those single things could involve fractions if you want them to, but you have to have just a single log on one side, a single log on the other side. No coefficients in front, no plus 5 afterwards, but you could in theory cancel logs. That's a skill that you could use. Over here, I was trying to show you the idea that, well, you could actually use the change of base rule, and then in addition to using the change of base rule, you could then convert the log out of log form into exponent form, and both would work. Here's some skills that I wrote down where I was trying to think of just, what are some of the things that if you're stuck, if you needed a list of okay, I don't know what to do, I'd say, okay, well, look at the first thing. Is that something you could do? If not, move on. Like my toolbox analogy? No. First one, would a hammer help? No. Okay. Second one, would a wrench help? Does that make sense? So kind of walking through skills. Do you know how to change an exponent into logarithm? And vice versa. So that's actually what we did in that last example there, right? Where you change the log into exponent form. 2, do you know how to add and subtract logarithms? Actually, we did that also in that example. 3, is the change of base rule applicable? Not even applicable, is it useful? Morning. Do you know the laws of logarithms that contain exponents? So that's where if you have an exponent up top, you can bring it in front, or if it's in front, bring it back up top. Number 5, don't forget that logarithms are just numbers sometimes. 6, by the way, sometimes you can kind of guess and check. If this was numeric response, you'd have a hard time being able to do anything with it. But if it was a multiple choice question, sometimes you can take the 4 answers from multiple choice, and you can plug them into your equation and see which ones actually work. Does that make sense? Or you could use your graphing calculator. What you could have done is you could have typed this equation into the graphing calculator. I don't know what it's going to look like. Then type 4 into the graphing calculator and see where they intersect. That is a skill you could use if you were stumped. The last skill, you can apply a logarithm to both sides of the equations. Or the opposite of applying a logarithm to both sides, you can remove a logarithm from both sides. So, anyways, let's do some more examples. Thoughts on this first one? Anything useful you see that you can do? Yeah, for sure. See how they're both log base 6? This is a valid time where we could remove the logs. So I'm going to remove that log, remove that log. 2x minus 1 equals 11. Add 1, 2x equals 12, divide by 2, divide by 2. X is 6. I did that too fast? You guys able to follow that? Okay. One thing I need to point out, by the way, when you guys are solving logarithmic equations, there is the possibility of extraneous answers. Yeah, should always test your answer. Here's what you need to test for, though. Take your numbers and just make sure that for whatever reason that you're not trying to log a negative number, because that's where the extraneous answers come in. Hypothetically, let's say that you had x, but x equals -4. Just like hypothetically. For me to check this, I would just go 2 times -4, that's -8, minus 1 is -9. and then I'd recognize you can't log a negative number. So that's usually where you need to check for extraneous, is just make sure that you're not being asked to log a negative. That's all. So that one's not the answer. Okay, thoughts on this guy here? Anything we could do that's useful? Change it into log form? Okay, that'll work. So I might say let's go log with a base of 7. Then it's going to be 4 to the number 40. And then that'll equal the exponent itself, which is x over 2. That's actually a great idea, Sean. I would point out right here, this right here, just a number. I mean, it's an ugly, stupid, irrational decimal number, but it's just a number. So all you got to do is times that number by 2. And you got your answer. So let's see whether I can use this calculator to find it. Log of 40 divided by the log of 7. Then times it all by 2. I got x to be 3.79, etc.
So when I'm putting it into the log form, how do you get it so then there's like an exponent on it or something? Or, I don't know.
Say that one more time.
Like to get like to the log to like the power or something, how does that happen again?
Okay, so the rule for that is, see how this guy's got a base and an exponent, and that's what it's equal to? This is an exponential form, and logs were developed specifically to try to isolate for this variable here. I hope this is your question. So then this is the base. This 7 goes down here as the base right there. This 40 right here is the solution. That goes right here, because then the exponent, which we were not previously able to get by itself, now over here, it's by itself. Did that answer your question or no?
I think I got confused. I think I thought the logs were meant to have an exponent. I don't know.
I mean, logs can also have an exponent, but they don't have to. Hypothetically, let's say that this 40 right here, though, had a 3 up top there. You could bring that 3 down in front, but that's not what applied in this scenario. Okay. Everybody good on the second one? Okay. So I want to show you a skill you can do on the next one here. This next one here, one of the issues is that, unlike in the previous example where I'd like to try to isolate for the single variable exponent here, you guys see how there's a variable up here, but there's also one there. So here's where I might recommend use the new trick of, let's just put a log on both sides. So here's how that would look. It's now log 6 to the power of 5x. And it's now log 3 to the 2x minus 1. A log is just an operation. It's just like adding something to both sides or multiplying something by both sides. In my mind, I think of it as like square rooting both sides. It would be valid to square root both sides of the equation, right? Well, when you log both sides of the equation, it just makes every number like a dumb, irrational number, but so does square rooting. So, any idea why I thought logging both sides was going to be helpful?
Bring the 2x minus 1 to the front.
And you can also bring the 5x down in front. There's actually a question in your assignment on the back page that uses this skill, if you guys were on that one already. So what this means is that you now have 5x, and you're timesing by log 6, and you have 2x minus 1. I'm going to make sure I'm really clear about this, though. The whole 2x minus 1 is timesing by log 3. Log 3, just a number. Log 6, just a number. So in a way, what I could do right here is I'm going to take 5, I'm going to times it by log 6, and I'm going to figure out what like the number portion of this little bit right here is. So 5 times log 6 means that this side right here I have 3.890756. I'm going to write it all down because I don't want to lose a digit. I have that many x's. Does that make sense what I just did there? This is a number, this is a number. I'm just multiplying them together, and that's how many x's there are. Just like if this was 5x and that was 3, 5x times 3 would be 15x. Well, 5 times log 6 just gives you 3 point that number x. Does that make sense? Okay, for this little bit right here, you've got to kind of FOIL the log 3 into the 2x and FOIL the log 3 into the minus 1. So if you do log 3 and you times by 2, Okay, so again, I'm just going to make sure I write down the whole digit because I don't want to lose anything. 0.945242509. That's how many x's you have. And then you also have to take log 3 and times by -1. So that's just really whatever log 3 is. So then I've got -0.477121.255. How do you solve this? X is all on one side, and then divide by whatever is in front of x when you're done. So I know it's ugly, dumb numbers, but so I'm going to subtract that from both sides. Subtract that from both sides. So that goes away. By the way, if you guys in your calculator, I'm using the little cheapo one here. But did I show you guys how to store numbers in your calculator if you don't know how? Okay, if you don't know how to store a number in your calculator, because this might be a time where it's useful actually. Should have shown you last year. I didn't actually learn it until this year though. If I know, I would have shown you. Would have. So if you do like say 5 times log 6, rather than rewrite that number, I might go store, which is right above on, and then go alpha A, I guess, to make it the number A. Because my calculator doesn't have the ability to go back up and find old values. Like your calculator will, right? So you can just go find those two numbers and subtract them. Because then when I want to do, what was it? It was like 2 times the log of 3. And then I might store that one as B. Then when I want to subtract these two numbers, I'll just do A minus B. And that's what this is going to be subtracted, the 2.936513742x equals -0.47121255. I think that number was log 3. And if I divide that by 2.936513742. Anyways, you guys able to solve for x? I got actually, this should be a negative. I missed a negative there. Anybody else get that? Okay, good. Okay, so the point I wanted to make on that one then, if you ever get a question where you have double...
Mr. Forster, please dial 103. Mr. Forster?
Expecting a lockdown at some point. If you ever get double exponents, maybe the best way of solving something with double exponents is to actually like bring down the exponents by adding a log to both sides. It's a useful skill. Questions on that? Okay, let's take a look at this guy right here. Can I cancel the log 5s?
No.
Fortunately, no, I cannot. So I need to choose a different method. Here's what I would recommend. I'm going to put the log 5, x minus 2, I'm going to put it on the other side. I'm going to add it to the other side. It's not the easiest to see here, but you have two logs that are being added to each other. We have a rule for that. What happens when you have two logs added to each other? Multiply. So I'm just going to make sure I'm very clear that this is going to be log base 5, and then I have to multiply the x minus 6 by the x minus 2. Now it's equal to 1. I would FOIL the inside, but can I do that in a second here? If you ever have just a single logarithm, sometimes the best way to get rid of a single logarithm is to go 5 to the power of 1 equals this stuff inside. I'm going to change that logarithm back to an exponent. And at the same time, I'm going to FOIL the stuff. Is that okay if I just do that in 2 steps? So I'm going to go 5 to the 1, and it's going to equal whatever that stuff was, which is x squared minus 8x plus 12. Bring the 5 to the other side. Means 0 equals x squared minus 8x plus 7. Did you minus 5 from both sides? It's quadratic, right? your two main options for quadratics are use the quadratic formula. That'll work. This one here you can factor though. Yeah, it needs to be x minus 7, x minus 1. That'll factor. So x is 7, x is 1.
Isn't 1 extraneous?
Nice, good catch, Justin. I mentioned it earlier. You gotta check for extraneous answers. You don't have to check very hard. Just make sure that when you have an answer, that the answer doesn't require you to try to get a log of a negative number. And as I look at 1 minus 6 would give you negative 5, and you can't try to log a negative 5. So 1 does not work extraneous. Does that make sense? Okay, let's try the next one here. Can I remove these logarithms? They're all log base 2. Can I just hack them all off? Not yet. I'm going to. That's actually going to be my strategy on this one here. But I can't hack them all off until I have log of something equals log of something, and that's it. So these two things right here, they're subtracted. What does subtract mean? If they're individually subtracted, then collectively you divide. Yeah. So you have log base 2 of x, and it equals log base 2, and I may as well just do this in my head. 18 divided by 6 is 3. This one's actually really easy. Yeah, now I can cancel the log base 2 of x. And x is 3. Yeah. Too fast?
Yeah.
Okay.
Yeah. Okay, so I understand the first part, but
Okay.
I don't understand how you got log with power.
Okay, so can I do like log base 2? Can I just do 18 divided by 6? Write it like that? Because the 18 minus 6 really means to divide. 18 divided by 6 is just 3.
Oh, okay.
Does that make sense?
Yeah.
And then after that, then we hacked off the log base 2's, and then x was 3.
Okay, that makes sense.
Yeah. Hopefully you guys kind of noticed these examples I'm picking. I designed them whenever I did this quite purposefully to try to show you like just a variety of different tricks that are useful, in different scenarios. Yes.
Okay. I just realized that.
You're good? Cool. Okay, 2 more, right? Then we're done?
Yeah.
All right. This guy right here.
Did you just put an exponential?
Not wrong. That's something you could do.
Oh, I guess it's just number.
Yeah, you just saw it there.
I didn't.
So Adriana's first thought, I think, was 1 over 5 to the power of x equals 7. That's not wrong. But I think I put this in as an example to point out, even though there's something that you can do, that wasn't helpful. This right here, I think her second instinct then was, don't forget, log base 1 over 5 of 7 is just a number. Yeah, so long as you know how to put that in your calculator, negative 1.20. So long as you know how to put that in your calculator, the answer is right there for you. So I think the point I want to make on that one is that you don't always have to go crazy and overthink things. I mean, in this example here, you didn't need to use a hammer and a nail. You could just use a piece of tape, and that would work just fine. Okay, last one. Any thoughts on this guy here?
Right, what answer did you get?
For the top one there, Devin told me negative 1.20.
That's what I thought.
Okay. I didn't check it myself, but
2, 1 is rounded.
okay. Okay. Okay, I have 2 main thoughts of how you could solve this one here. So maybe I'll try taking 2 different paths. The first one I think of is that 5. I can put that 5 down in front. That's a rule that I could use, right? Now, the only reason I'm going to suggest that 5 dropping down as front is useful is there's a 5 right here. There's a 10 right here. I should be able to divide both sides now by 5. If this number up top here hadn't been a 5, let's say it was a 4, I don't know that I would find that skill as useful because 10 does not really evenly divide by 4. But 10 totally evenly divides by 5, so you're going to have log base 3, x squared minus 8x. Now it's equal to 2. I would say most of the time that you see a single logarithm, one of the strategies you have to consider is let's change it to an exponent. Because that's really all I think I have left at this point here. So to make this guy an exponent, the base was 3. The new power is going to be 2. And it now equals x squared minus 8x. Okay, so squaring 3 is just 9. Would it be okay if in multiples, I just combine 2 steps? Make that 9, and then bring the 9 to the other side, so that you have 0 equals x squared minus 8x minus 9. It's quadratic, so you'll get, what, x minus 9, x plus 1, which means x is 9 and negative 1. Yeah, I should double check that, though, before I go too fast here. Negative 1 squared is 1. Then you're minusing 8 times negative 1. Like 8 times negative 1, negative 8 times negative 1 is actually adding. So actually negative 1 doesn't seem to give a negative under the logarithm, so I don't think that's actually the problem. I should double check 9 though. 9 squared is 81. And then you minus 8 times 9. 8 times 9 is 72. No, that still works. I feel like both of these probably should work. So I wouldn't always default to just because you see this being a negative number, saying it's extraneous. Because just the way the equation worked, it could be positive. One more thought, then I'll let you guys take a break. I do have another thought as to how to solve this one. So that was route 1. Can I try route 2 just as another suggestion? Hypothetically, let's say that bringing that 5 down in front didn't cancel nicely with the 10. Because that was very convenient for us. But what if this wasn't a 5? What if it was a 7? Bringing a 7 down in front, 10 and 7 is going to be kind of ugly. Does that make sense? So I have another strategy. What we could have done is right off the bat, I could have just gone 3 to the 10 equals x squared minus 8x. But I'm going to leave this guy to the 5. Okay, I should explain that maybe. I'm going 3 to the power of 10. And then the leftover bit is this part right here, but this part right here I'm leaving the exponent. Here's my suggestion then. Just draw a line here. 3 to the 10 is just a number. I know it's a dumb, really big number. But apparently it's 59049 equals x squared minus 8x to the 5. Yes, that's the point I was going to make. Some people, they look at this exponent here and they think, I should actually write it next to itself 5 times and FOIL it. I bet you, if there was a 2 right here, most of you would have thought, let's FOIL it. And not that foiling it's wrong, but it's not a helpful tool in this case. Fifth rooting it is actually way more useful. So I needed some help because my calculator, I don't know how to do the fifth root of 59049. 9? Which I think gets us to the exact same point that we were at basically right down here. It might be. Alright, that's my lesson. Basically, I just wanted to show you a variety of like random little tricks you can play to help you solve. Ultimately, it does not matter how you solve, so long as you find a way. If it's multiple choice, to be honest, I wouldn't even try solving. I would guess and check the 4 answers to save my time. I'm going to say that again. If you get a question where they ask you to solve a logarithm and it's multiple choice, I'm not even sure that I would. I think I would take the 4 answers they give me, A, B, C, D, and I would just guess and check the 4 answers and see which one it is. Because that might be the fastest way of doing things. Does that make sense? That being said, that won't always work. If it's numeric response, which in my recent experience would tell me that they like to give a question like this that's numeric response, so you can't guess and check, then you have to have a variety of skills. However, you do have a backup option. You can always type one half of the equation into y1, the other half of the equation into y2. You're going to get 2 graphs. I have no idea what they'll look like, but those 2 graphs will cross somewhere. If you can find where they intersect, that would also work. That makes sense? Or preferably, I also want you to have some algebra skills as well. Like, you shouldn't just forego algebra skills. What's that? Yeah, I want you to know some math, but I also want to give you guys some like smart test taking skills too. So. All right, any questions? All right, that's the unit, guys. We've done the unit. Give me a sec. So here's the plan then. Tomorrow's a work day. Thursday we're gonna write our second quiz. It's written response still. Friday's Flex Friday. Can I have your assignments by Friday? Is that doable? And then next week, Monday's a work day. Tuesday's a multiple choice quiz. Wednesday is a work day. And then Thursday is a multiple choice unit test. So basically, we're doing a whole bunch of tests now. And then after that, the Friday's Halloween.
Well, not Halloween.
Well, yeah, the Friday
It
Halloween.
makes me so sad. I'm trying to get a position of school. Like, usually get first class and then we don't.
All right, you guys good? All right, cool. Go take a break if you need to. I'll pause the recording here.